Hey everyone, welcome to another BTM screencast, and again we're going to be using the carpentry book for a masonry application. In this case, we're going to be talking about concrete and flatwork forms. So footings are the foundation of the foundation, if you want to think of it like that. They provide a base to spread the load of a structure over a wider area, right? So think if you have a knife and you're cutting through something. The knife is nice and thin, it's sharp, it'll cut right through. But if you turn that knife sideways and try to go through, it's a little tougher. And that's what we're trying to do is just spread that out and make it tougher to push through. They're made in varying styles, and forms are constructed to contain concrete. Soil is not allowed to be used as a footing form. So here we have a different approach for different things. At the bottom, we have different types of piers. This up here is a continuous or spread footer. Up here we have a monolithic slab, which is the footer, wall, and the slab with it. This is a grade beam. You may have seen these in, well, like underneath bridges and stuff like that. Here's an example of a footing. We're not going to get into detail with this. This chapter has a lot of good stuff on formwork, which is what we're going to be focusing on for your performance assessment. This is kind of like what a footer looks like typically. Now, you have a footer in between here. These are piers. There's more reinforcement, and then you just run up. And you're able to put your either like a block wall or a concrete wall on top. Locating footings, again, we're just going to gloss over this. It's not too relevant to what we're doing. Footing forms. So keyway provides a lock between the footing and a foundation wall. May be necessary to step the footing on sloped land, and column footings are placed at the same time as wall footings. So this is an example of a step footing. You could see that this is necessary to maintain the right depth, and because we're on a slope, we need to make this so we could put a wall up. We can't run a wall sloped, right? If you remember from last year, needs to be level, needs to be plumb. So we need to make up that difference and create a step instead of a hill. This is a keyway. Again, not too relevant to what we're doing. We're going to be more focused on this part, the formwork. Forms for slabs. This is what your performance assessment is all about. Slab on grade slabs must meet basic construction, must provide good drainage, must have well compacted base, treat it chemically for termites, install all of the mechanicals before placing the concrete, should have a vapor barrier or vapor retarder, should be reinforced with wire mesh. Wire mesh is also known as welded wire fabric. Monolithic slabs. So we went over this one. Again, if you want to read into this, or if this is something that you want to get more in depth with, let me know, and then we can explore that. So this is what a monolithic slab would end up looking like. And again, not necessarily what we're focused on for this one. Independent slabs. In colder climates, footings must extend below the frost line. That includes here, right? Because when you have something that freezes, frost helps stuff expand, right? You want to be below that. You don't want to set a building and then have a footer that's above frost, because if you have it above frost, the frost will cause it to heave. You don't want your building moving. That's not cool. It's not what we do. So you want that below frost depth. Once it's below frost depth, it's not going to go anywhere. It just sits there. In these areas, concrete slab and foundation wall may be separate. Slab insulation is required in colder climates. So here's some pictures of what that looks like. Again, not entirely relevant to what we're doing, but you should be aware of this and how it ties in to the overall structure of a house or a building. Forms for walks and driveways. So this is what we really want to focus on. for our walks and driveways should be constructed to drain surface water away from the building. So we always want stuff pitched away from the building, right? Pitched away. You don't want water flowing into the building. There's a really good example of this right outside our door. So the parking lot, for whatever reason, is actually pitched towards the building. You don't want that. You don't want water coming in. Uh, you just don't. And not only will it be water, but in the wintertime, that'll turn into ice. And you don't want ice around a building for obvious reasons. Sometimes there are curved walks and driveways. So when you're in the field, this is referred to as a radius. So here we have this, and this is generally what we're looking at. So these are our control joints. These are typically 25 to 33% thickness of the slab. So if our slab is 4 inches thick, which is typical, this needs to be an inch or more. And what this does is this will create a crack, but it'll crack where you want it instead of where it wants to crack. The edging, this puts a nice radiused edge, so a rounded edge against your formwork, and it gives a much cleaner, neater appearance, and it actually creates some strength in that corner. These are our side forms, so we're going to be looking at these. This is a bulkhead, which we won't need to worry about because you're just going to be doing squares. When you have a keyed bulkhead, it allows it to tie in to the next one. So they have up here, we have a screed, also known as a straight edge, and this just helps you go from side to side and make sure that you're at the right height according to the formwork that you have in place. This says stakes at 4-foot intervals. I don't agree with that. Typically they're done as needed. Sometimes, most times, it's going to be less than that. So this is explaining how to do a radius. If you guys want to do radius for your things, let me know, and we'll talk about that. So typically what you can do is take a saw, and we will kerf out some of it to help it bend. We have plywood, we'll be able to do that, and then there's certain ways that you need to reinforce that. And here's another example to give you the steps. Again, if you want to create radius formwork, let me know. It's going to be a little tough because the areas that you're making are relatively small, but it's doable. So in conclusion, concrete for footings have various styles. So we went through those again. It's important to know generally, specifically right now. If you want to get more in depth, let me know. Slabs, walks, and driveways are placed on stable soil below the frost line, right? Because again, you don't want it heaving. You must consider the drainage and local codes. So depending on where you're working, there will be different requirements for the type of concrete that you use, the different types of pitch you have to use, and stuff like that. And you may be able to form it with curves or create a radius in that. That's it, and I'll see you next time.